Hello everyone. Today we are going to discuss JMN 2022 paper that was held on 26th June, and this is of morning shift. Let's see the first one. Most stable enol form will be shown by which of the following? So these all are diketones, and where it is triketone. And if we just draw the enol form for the third one, we are getting the most stable enol, as it will convert into aromatic ring. Okay, so it will be 135 trihydroxybenzene. So because of this aromatic enol, this is going to be most stable. So the correct answer for the first one is fourth. Now let's move to the next one. Now this is the Grignard reagent, and it is treated with this acetyl acetone. We have two carbonyl carbon. So this Grignard reagent, nucleophilic carbon, basically this one, will attack here. So this will attack to this, and this will leave. This will attack to this carbon, this will leave. So we will be getting 1, 2, 3, 4, 5, a 5-membered ring. So this will be 5-membered ring. Okay, and on this we have O negative, right? After the acidification, this will convert into OH. Okay, so the final product that we will be getting is this one. So if you see, the correct answer is the fourth one. Okay, so this is just a nucleophilic addition reaction by Grignard reagent. Next. Now, this is benzoyl peroxide, and in sunlight it will dissociate. It will undergo homolytic dissociation, forming intermediate, and further by evolution of CO2 gas. Okay, this is going to form phenyl free radical. So they are asking you what is that intermediate. So first let me draw the structure of benzoyl peroxide, that is PH, CO, O, O, CO, PH. Okay, with photon it will be homolytic dissociation, bond cleavage, so it will form two equivalent of this PHCO, O, intermediate. So intermediate is similar to what? Third one. So this is going to be your answer. Further, what will happen? There is a rearrangement like this, and this will form phenyl free radical plus CO2. Okay, let's move to the next one. They are asking you the correct order of melting point of group 16 element in oxygen family. So if you see, the elements are oxygen, sulfur, selenium, tellurium, and polonium. And if you see the data in NCERT that is given, the oxygen has a melting point of 55 Kelvin. Then sulfur is 393 Kelvin. After that, selenium is 490 Kelvin. And tellurium is 725 Kelvin. Polonium is radioactive, but this is not in the option, so leave it. So maximum is tellurium followed by selenium. So tellurium, then selenium, then sulfur, and then oxygen. Oxygen is having the least, melting point. So tellurium maximum, selenium, sulfur, oxygen. So this is going to be your answer. Here it is mistake, basically. It is like this. No, sorry, it's not mistake. It is correct because tellurium is greater than selenium, but selenium is greater than sulfur. So there is some mistake. This is incorrect. So correct one is the second one. Now let's move to the next one. White phosphorus plus alkali are giving the product H. Okay. So white phosphorus with sodium hydroxide undergoes a disproportionation reaction. And the product we know is a very important reaction, that is PH3 plus NaH2PO2. Okay, so from 0 it is going to -3 and it is +1, and we can say this is getting reduced as well as getting oxidized. So this is a disproportionation reaction, and in this case the product that we are getting is phosphine. So phosphine is not in the option, so other product is this NH2PO2. So you can break it like Na plus and H2PO2 minus. So it's the fourth one. That is the correct answer. Now if you heat this further, again there is a disproportionation and it will form PH3 and Na3PO4. Okay, let's move to next question. Now question is, which is responsible for secretion of pepsin? So basically the histamine, that is directly from the chemistry in everyday life NCERT, where it is given that histamine stimulates the secretion of pepsin and hydrochloric acid in the stomach. So basically the first one is the correct one, that is histamine. Next, which of the following set of match is correct? Okay, copolymer is Buna-N. So basically Buna-N is copolymer of 1,3-butadiene and acryl nitride. So this is correct match. Condensation polymer is nylon 6,6. So yes, it is condensation polymer of hexamethylene diamine and adipic acid. So this is true. Fiber is nylon 6,6. So this is also true. Nylon 6,6 is fiber. Nylon 6 is fiber. Thermosetting polymer is terylene. This is wrong. Terylene, that is polyester, is a fiber, not a thermosetting polymer. Bakelite is thermosetting polymer. So it is 1, 2, and 3 that are correct. So it is the first option. Let's move to the next one. Now, this is from the POC, 11th class. In Lassine test of organic compound, including both nitrogen and sulfur, sodium thiocyanate is formed. That is correct. If it is carbon and nitrogen, then cyanide will form sodium cyanide. If nitrogen and sulfur both are present, then sodium thiocyanate is formed. That is correct. That is basically SCN minus. Now, statement 2, excess of sodium plus sodium thiocyanate is giving you sodium sulfide and sodium cyanide. This is also correct. This, in fact, this reaction is given in NCERT. If you see the chapter POC, it is given, mentioned. So statement 1 and 2 both are correct. So it is the first one. Next one. Next is the correct order of melting point of group 16 hydride. So in group 16 we have elements like oxygen, sulfur, selenium, tellurium, polonium. Their hydrides are H2O, H2S, H2AC, and H2TE. If we see the order of the melting point, H2O is having the highest melting point as well as highest boiling point because it's H2O. It's intermolecular hydrogen bonding, right? And after that, melting point and boiling point is governed by molecular weight. Then it will be H2TE, then it is H2AC, then it is H2S. Because H2TE is having the highest molecular weight, so it will have highest van der Waals forces of attraction. So the correct option will be the second one. So in this case, melting point and boiling point follow the same order. H2S is most volatile as well as having the least melting point. Next. The correct decreasing order of the bond order of the following species is. So we'll quickly calculate the bond order. It has total of how many electron? 18 electron. For 18 electron, bond order will be what? 1. Okay. Now this is total 17 electrons, so its bond order will be 1.5. 16 electron, then bond order is 2, and it is 15 electron, then bond order is 2.5. So if you see the correct order of bond order, it is going to be the fourth one. And suppose it is O2 2 plus, then it has 14 electron, and in this case bond order is maximum, that is 3. Okay. Now let's see the next one. The radius of the third orbit of hydrogen atom is R3 picometer, and radius of the fourth orbit is R4 picometer. Then the radius ratio is what? So you know that radius is directly proportional to n square by z. Z is same for both, so R3 by R4 will be simply equal to the orbit number square, that is 3 square by 4 square, that is 9 is to 16. And if you see, the correct answer is the first one. Okay. Now let's move to the next one. That's the question number 12. Now the statement is, as the value of delta G naught decreases, the melting metal oxide becomes more stable. That is true. It is directly based on Ellingham diagram, and the Ellingham diagram is basically delta G naught versus temperature. And you can see the metals like aluminium, calcium, okay, are having this metal to metal oxide curve lying below, where the mercury and silver like will be above that. It is showing that for the formation of L2O3 there is more negative value of delta G naught, so L2O3 is more stable, whereas Ag2O is less stable because its delta G naught formation is less value in negative. Okay, so first one is correct. Second, as the value of delta G naught increases, then the metal having lower value of delta G naught displaces the other metal. That is also true. So we can say that if you compare the value of delta G naught for L2O3 and Fe2O3, L2O3 has more negative. So Fe2O3 with aluminium will replace this, forming L2O3, and Fe will be reduced from +3 to 0 oxidation state. Why this reduction is possible? Because Al2O3 is having lower value of delta G naught, so it is more stable oxide as compared to that of Fe2O3, and that is used in thermite welding. Next, so here both the statements are true, so it is the first one. Now let's see the next one. Question is, which of the following is wrong about brown ring test? Okay, so brown ring forms at the junction of the two solutions. This is a correct statement. Brown ring complex is this one, FeH2O5NO plus SO4. That is also true, where iron oxidation state is +1. It consists of ferrous nitrosulfate. That is wrong. Ferrous means iron is +2, but here it is iron +1. That's why it's some mistake. Now nitrate ion plus sulfuric acid plus FeSO4, that is missing here. We'll be getting brown fumes. Yes, because we are getting NO, which will get oxidized with air to form NO2 gas. That is a brown fumes. So basically the last one is also correct. So 1, 2 and 4 are correct, whereas third one is incorrect. Let's move to the next one. The correct order of stability of +1 oxidation state of group 13 element H. So elements are boron, aluminium, gallium, indium, thallium, and due to inert pair effect, +1 oxidation state increases down the group and +3 oxidation state decreases down the group. So Al3+ is most stable, followed by gallium 3+, then indium 3+, and then thallium 3+. This is the stability of +3, but due to inert pair effect, if we see the +1 stability, maximum will be of thallium. Okay, so thallium +1 is most stable. So thallium followed by indium, then gallium, then aluminium. So this is basically the second option. Let's move to the next one. Now, the increasing order of melting point of alkaline earth metal H. So the melting point trend in alkaline earth metal is not regular basically, and it is due to strong electropositive nature of the alkaline earth metal, and basically comparatively low ionization energy with compared to your D block metals. So in that case, the order is beryllium is having the maximum, then we have calcium, then we have strontium, then we have barium, and minimum age of Mg, magnesium. That's the order of melting point. So if we see carefully, the second option is the correct one. So this question is directly data based. Okay, so it's less conceptual, more is the data based. So the correct answer is second one. Now let's move to the next one. 35% by mass of HCl. solution has density of this much, find the molarity. Okay, so basically we'll just write the formula of molarity. What is the molarity? We need to know the number of mole of HCl divided by volume of solution in liter. Okay, that we need to know. Now 35% mass of HCl means 35 gram HCl, okay, is present in 100 gram of solution, right? So 100 gram solution means what is the volume of solution? Because 1 ml is 1.46 gram. So 100 gram means it is how much ml? We have to just divide 100 by 1.46 ml. Okay, this is the volume of 100 gram, and 35 gram means how much mole basically. So you know that HCl is 35.5 plus 1. So its mole is 35 by 1 plus 35.5. So we can say simply that 35 by this mole of HCl is present in this much volume. So now the calculation of molarity is much easier. We'll just take this mole. So it is 35 by 36.5. Okay. And we'll take this volume that is corresponding to this mole. But we have to convert this into liter because that is in milliliter. So we have to divide by 1000 and that's all. So we just need to solve it. Okay. After solving, we'll be getting it to be exactly 14 molar. So that is the second one. Next, ethyl anthraquinone is oxidized to form ethyl anthraquinone and the compound X. The dihedral angle X in the solid state is. So basically ethyl anthraquinone is this one. Let me draw the structure here. Yeah. So this is the ethyl with ethyl anthraquinone. Here it will be ethyl group. Okay. Now when it is oxidized, basically we get hydrogen peroxide and ethyl anthraquinone. So ethyl anthraquinone will be this one. And the other product we'll be getting is hydrogen peroxide. Now basically the X is hydrogen peroxide and they are asking you the dihedral angle. So in NCERT the structure is given in solid phase as well as gas phase. In solid phase the dihedral angle is 90.2, whereas in gas phase it is around 111. So 111.5. So this is the gas phase angle. They are asking you solid phase. So correct answer should be 2. Now the next one, 0.30 gram of organic compound on combustion is giving 0.3 gram of CO2 and this much gram of H2O and side product. Find the percentage by mass of carbon present in this. Okay. So all the carbon that is present in the organic compound is being converted towards CO2. So what is the amount of CO2? 0.30 gram CO2. So what is the mole of CO2 here? Mole will be 0.30 by 44. This will be the mole of CO2. Then mole of carbon will be same as that of CO2 because in one CO2 molecule there is one carbon atom. So the same. Now if you calculate the mass of carbon, so it will be how much? 0.3 by 44 into 12, this much gram. Okay. Now they are asking you percentage carbon, right? So percentage carbon means mass of carbon, that is 0.3 by 44 into 12. Okay. Divided by total mass of organic compound into 100. That we need to solve basically, and we'll be getting the percentage carbon in that. So let's solve it. It is 0.3 into 12 by 0.3 into 44 into 100. Okay. So now this 0.3 and 0.3 will get cancelled out. Okay. Now we have total 1200 divided by 44. 1200 by 44. And that will be how much? 27.27. Okay, so that is going to be the correct answer in this case. Now let's move to the next one. Consider the following radioactive decay and find the number of alpha and beta particles emitted. It is uranium 238 giving you Pb 206, right? So we know that when alpha emission takes place, what happens to the atomic number? Atomic number is decreased by 2 and mass number is decreased by 4. Okay, and when beta emission takes place, nothing happens to the mass number. Atomic number increases by 1. Okay, so whatever is the change in the mass number, that is 238 to 206, will be due to the alpha emission only. And we know that each alpha emission there is 4 decrease in mass number, 4 decrement. So if you divide by 4, you'll get the number of alpha particle. So it will be how much? 32 by 4, that is 8. So that is your alpha particle number, that is 8. Now, coming to the beta. Okay, when there will be 8 alpha particle. Okay, then what will happen to the atomic number? Atomic number should decrease by how much? 16. Should decrease by 16. So now, yeah, there is a mistake in the question itself. Lead, if you see the lead, the atomic number of lead, here it is wrong. Okay, it is 82, not 92. So let's make a change here, 82. Yeah. So it is 16. So atomic number after, emission of 8 alpha particle, there will be total of 16 decrement in the atomic number. Okay. So this will give you how much? 92 minus 16. If you just do, you will be getting 76. But now the atomic number is 82. So it has increased its atomic number by 6. So it will be 6 beta particle emitted, and that will cause this atomic number further to decrease to 82. So the number of beta particle is basically 6. So total number of alpha plus beta, that will be 14. That will be the answer for this. Let's say the next one. Now the polar stratospheric clouds results in the formation of. So the polar stratospheric clouds basically provide the surface on which chlorine nitrate formed gets hydrolyzed. Okay, so we have ClO free radical that will be reacting with NO2 gas and will be forming ClO NO2, that is chlorine nitrate, and this chlorine nitrate will get hydrolyzed here, okay, and will form hypochlorous acid, that is SOCl plus HNO3. So overall this reaction will take place. So here it is result in the formation of first chlorine nitrate as well as HOCl. So the correct answer will be 1 and 2 both. Let's see the next one. A compound reacts with dilute HNO3 gives a product A and B, which can be separated using the steam distillation. When reacted with concentrated HNO3, it gives P. Name the product P. So that is very simple. That compound itself is phenol, and we have seen just in the previous, JMN paper, this was asked that when we are treating with dilute HNO3, we'll be getting mixture of these two products, O-nitrophenol and P-nitrophenol. O-nitrophenol is more stable and major here because of intramolecular hydrogen bonding, and they are separated by steam distillation. So we can separate them by steam distillation, but when it is concentrated nitric acid, okay, when we treat with concentrated nitric acid, we get picric acid, basically picric acid. So the correct product P is the first one, picric acid. Let's see the next one. How many oxygen atoms are present in nucleotide which is only present in RNA? Okay, so nucleotide that is present in RNA is uracil. So if you see the structure, this is uracil. Okay, so this is the nucleoside which is, present. It is not nucleotide here, nucleoside. It will be nucleoside, okay, which is present in RNA. That is a, uracil. And this will be what? Having how many oxygen atom? That is only 2. So the correct answer will be 2. Now, next one. 0.5%. It is weight by weight. KCl solution has depression in freezing point of 0.24 Kelvin. Calculate the degree of dissociation of KCl. So we know that delta TF equal to IKFM. Now depression in freezing point is 0.24. So 0.24 equal to I into Kf value is 1.86 into molality. Molality is mole of KCl. So 0.5% weight by weight means 0.5 gram. Okay, and we need to convert this into mole. So formula mass is basically 74.5. So this is the mole. Okay. Now 0.5 gram is present in 100 gram of solution. So what is the mass of solution in kg? Solvent in kg. So basically 100 gram solution means 0.5 gram is your solute. So 95.5 gram is your solvent, and divided by basically 1000 will convert this into kg, right? Because the formula of molality is what? Number of mole of solute. This is the mole of solute present in 1 kg of solvent. So this is the mass of solvent in kg, right? So mass of solvent in kg. Now from that we'll calculate the value of I, and if you do it, the value is 913. This is coming. And for KCl, we can write I simply equal to 1 plus 2 minus 1 into alpha, where alpha is degree of dissociation. And just solve it, you will be getting alpha value as 0.913. That is 91.3% will be dissociated. Now let's move to the next one. Next is they're asking you number of oxygen atom present in the picric acid. So if you see the picric acid structure, that's the same product that we have got when phenol was treated with concentrated nitric acid. So this is phenol, an explosive compound and very much strongly acidic. It has 2 to 4 to 6 and 1 7. 7 oxygen atoms. So that's the end of this discussion. We have completed this paper. Thank you.